In this video, I will show you how to graph an equation using table value. This is the most fundamental method to graph any equation. It doesn't matter whether the equation is linear or non-linear, and you have to know this concept in statistics. It is very important. All right, so let's start with a pretty simple equation. I have y equals to x minus 1, and then the way I'm going to do it is I will set up a table, pick a few x values, and then plug it in to get the y values, and then I will plot all the points on the graph and then show you the graph of this equation. So first I pick x equals to -3, -2, right? So I already picked the x values. So what we can do is we plug it in. So y is equals to -3 minus 1. So that is equals to -4. So my first order pair is -3 comma -4. And then the next one, y is equals to -2 minus 1. That is equals to -3. So I have -2, -3. And then y equals to -1 minus 1 equals to -2. So we have -1, -2. Y equals to 0 minus 1. We have 0, -1. Y equals to 1 minus 1. We have 1 comma 0. Y equals to 4 minus 1. We have 4 comma 3. Y equals to 6 minus 1. That is equals to 5, right? Equals to 5, so we have 6 comma 5. And then, so before we do the plotting, do we agree that I can keep choosing different x value, right? So I can pick x equals to, for the negative, I can pick -4, -5, -6, -7, so on and so forth. For the positive, I can pick 7, 8, 9, 10, 20, or even 1,000, right? So the idea is every time you plug in an x, there is a y value. All right, every time you plug in an x, there is a y value. And then do you see in column 3, I have a bunch of order pair x comma y. So that means this equation has infinitely number of possible solutions because there is a y value for each x value you choose. So every time you pick an x, there is always a y, right? So if we keep doing this, we will get infinitely many order pairs. That means this equation has infinitely many solutions. So let's just focus on these 7 solutions. So the first one is -3, -4. So we plot that -3, -4. And then we have -2, -3. And then -1, -2. And then 0, -1. Do you see the pattern? Do you see that? The pattern. And then the next one is 1, 0. And then the next one is 4, 3. So 4, 3. And then 6, 5. All right, so these are the points we have based on the table. So by catching this pattern, so let me pick another color for that. So I can easily pick all the other points out. So they are right here, right? So this is the pattern. So I can easily grab the rest of the points. So what are these points represent? These points represent the solution of this linear equation. So let's say we pick the highest point, x is equals to 9, right? X is equals to 9, y is equals to 8. So we pick a point, so x is equals to 9, y is equals to 8. So you plug it in. When y is equals to 8, we have x minus 1. So that works, right? And then you pick another point. Let's say 8 comma 7. 8 comma 7. So when x is equals to 7, we have 8 minus 1 equals to 7. So this point is a solution of the linear equation because they fit into the equation perfectly. And then what is the graph? The graph is, all you have to do is you sketch a line, you draw a line that connects all the points. So here is the line. Make sure the line is straight, and then you draw an arrow on each end. Why do we put an arrow on each end? Because we can keep on going. I can pick x equals to 10, 11, 12, 13, 14, 15, 16. So we can keep on going. So you must draw an arrow on each end. And also, you have to make sure your line is straight. So this is how to graph an equation using table value. It's the most fundamental way. It doesn't matter how complicated the equation is. As long as you know how to use table value, you can always get the graph of the equation. So what is this equation called? This is called a linear equation. Why is this called a linear equation? Because x is raised to the first power and y is raised to the first power. As you can see, the graph of this equation is a straight line. So straight line, we call that a linear equation. All right, so we have more exercise on the following pages. So this one, I have an equation 2x plus y equals to 4, and I want you to check these 4 order pairs, and then I want you to sketch the graph of the equation for me. So let's check the first one. When x is equals to 2, y is equals to 0, do we have a balance? So this is 4 equals to 4. Yep, that is a solution. When x is equals to 0, y is equals to 4, that is equals to 4, so 0 plus 4 equals to 4. Yep, that is a solution. When x is equals to 3, y is equals to 1, is that equals to 4? 6 plus 1, nope, that is not equal to 4. And then the last one, when x is equals to -1, 2 times -1 plus 6 equals to 4. So this is a -2 plus 6 equals to 4. Yes, 6 minus 2 is equals to 4. So what we have to do is we plot the 3 yes. So the first one is 2 comma 0. X is equals to 2, y is equals to 0. And then x is equals to 0, y is equals to 4. And then x is equals to -1, y is equals to 6. So we have these 3 points. And then how about the 3 comma 1? The 3 comma 1, I will graph that using a different color. So the 3 comma 1 is right here. Okay, so let's go back to the orange, and then I will connect these 3 points to get a straight line, right? So this is my straight line. So that is the graph of the linear equation, that which is 2x plus y equals to 4. And then since you can keep picking x, right? So you can pick x equals to 3, 4, 5, so on and so forth. That means you have to extend this straight line all the way down, and then finish that with an arrow, and then extend the line all the way up, and then finish that with an arrow. So how about this point right here? This is a 3 comma 1. This 3 comma 1 is not on the line. So 3 comma 1 is not on the line. Why? Because this 3 comma 1 is not a solution. So you look at this straight line. If you can pick a point, and that point is on the line, that means this point. So you can keep picking points. So these points, they are on the line, right? So that means if you take that order pair can be fit into the equation. You can easily fit the x and y coordinates into the equation, and the equation is balanced. If you pick a point, so for example, the blue point 3 comma 1, that is not going to fit into the equation. So overall, we use table values to sketch the graph of a linear equation. So every point on the line is a solution, and all the points not on the lines, they are not solutions. All right, so let's move on to more exercise. So we have more right here. So I have an equation, I pick some x values for you, and then you use this table value to sketch the graph for me. So y is equals to -x minus 3, so that is equals to 3 minus 3 equals to 0. So you have -3 comma 0. Y is equals to -2 minus 3, that is a 2 minus 3 equals to -1. So this is a -2, -1. And then y equals to -1 minus 3, that is 1 minus 3 equals to -2. Then we have -1, -2. Y equals to -0 minus 3, so that is -3. Then we have 0, -3. And then -1 minus 3, 1, -4. We have -2 minus 3, so that is 2, -5. Plot them, so -3, 0. And then -2, -1. And then -1, -2. So eventually, you will see what the pattern is, right? So 1, -4, and then 2, -5. So you have these 5 points, and you can clearly see the pattern. The next point is we go 1 step left, and then we go 1 step down, right? Okay, so you connect them, make sure your line is straight, use a ruler if possible. So this is the graph of the given equation. What is the equation? The equation is y equals to -x minus 3. So the graph of y equals to -x minus 3 is this straight line. And then of course you can keep picking x values, right? You can pick x equals to 3, 4, 5, so on and so forth, which means you have to extend this line all the way down and then all the way up. Make sure your line is straight, and then you finish that with an arrow. That means this equation has infinitely many solutions. And then I have an extra question right here. So I have another point. That point is negative 4 comma 5. So negative 4 comma 5 is right here. Is this a solution? The answer is no. Why? Because this is not on the line. So you can do a quick check. So using a graph, you can see it, right? It's not on the line because you can see it. What if the graph doesn't exist? Then you have to take a quick check. So when y is equals to 5, we have negative x minus 3. So 5 is equals to 4 minus 3. That is not true. So that means the given order pair is not a solution. And again, if a point is on the line, that point is a solution. If a point that is not on the line, then that point is not a solution. So you can keep picking points right here. They are all on the line, right? So that means they are all solution. But you have to make sure your line is straight. Otherwise, the points will be off. Okay, so that is the end of this problem. Let's move on to the next one. So the next one we have 2 right here. So let's do the one on the left first. We plug in. So we have y equals to negative 2 times negative 3 plus 1. So that is 6 plus 1. Negative 3, 7. And then y equals to negative 2 times negative 2 plus 1. So that is 4 plus 1 equals to 5. And then y equals to negative 2 times x plus 1. So that is 2 plus 1 equals to 3. And then negative 2 times 0 plus 1. 0 plus 1 equals to 1. And then y equals to negative 2 times 1 plus 1. So that is negative 2 plus 1. Y equals to negative 2 times 2 plus 1. So that is negative 4 plus 1. Y equals to negative 2 times 3 plus 1. So that is a negative 6 plus 1, negative 5. So we have negative 1, 3. And then 0, 1, and then 1, negative 1, and then a 2, negative 3, and then a 3, negative 5. Plot them. So negative 3, negative 7, and then negative 2, negative 3, positive 7. What a big mistake. Negative 3, positive 7, and then negative 2, 5, and then negative 1, 3. 0, 1. Do you see what the pattern is? 1 unit to the right, 2 units down. And then 1, negative 1, 2, negative 3. Now you can go fast, right? And then 3, negative 5. So the next one, without doing any math, I know that must be 4, negative 7. Because the pattern is 1 unit to the right and 2 units down. And then use your ruler, sketch a straight line, connect all these points, and then finish that with an arrow, and then same thing on the other side. So this is the equation of y equals to negative 2x plus 1. So let's do a quick test. So every single point on the line is a solution, right? Let's pick a point that is not on the line. So let's say I pick this one. This one is 4, 3. That is not on the line, right? So that must be not a solution. Let's test the point. So when y is equals to 3, we have negative 2 times 4 plus 1. So 3 is equals to negative 8 plus 1. That must be a joke. So that's why the point is not on the line. So that point is not a solution. Okay, moving on to the equation on the right. Switch to another color. So we have 2/3 times negative 9 minus 2. So that is negative 3 times 2. So that will be a negative 6 minus 2. Negative 8. So we have a negative 9, negative 8. And then 2/3 times negative 6 minus 2. So that will be a negative 4 minus 2, which is a negative 6. So we have a negative 6, negative 6. And then a 2/3 times negative 3 minus 2. So that will be a negative 2 minus 2. Negative 4, so that is a negative 3, negative 4, and then 0, that is easy, minus 2, so that will be a 0, minus 2, 0, negative 2, and then we keep on going, right? So 2/3 times 3 minus 2, so that is a 2 minus 2, and then 2/3 times 6 minus 2, so that is a 4 minus 2 equals to 2. 2/3 times 9 minus 2, so that is a 6 minus 2, 4, 9, 4, and then 6, 2. So they are all solutions, right, of the given equations. And now let's plot them. Oh, by the way, you have to label your x and y axis. So y and x, and then y and x. Okay, -9, -8. So -9, -8 is in quadrant 3. So that is -7, -8. So -9, 8 is out of the picture, but I can see that that is right over here. And then -6, -6. That is right here. -3, -4. And then 0, -2. Do you see what the pattern is? The pattern is you go 3 units to the right, and then you go 2 units up, 3 units to the right, 2 units up, and this pattern has a specific name, which is, and it is super important. We need to know that in statistics. I will introduce what this pattern is in the next lesson. And then the next one is 0, 2, we have 3, 0, and then 6, 2, and then 9, 4. All right, let's connect this point. Make sure the line is super straight. There you go. All right, so that is, this equation is y equals to 2/3 x minus 2. So that's how we graph a linear equation using table value, and you need to fully understand this in statistics, especially the pattern. 3 units to the right, 2 units up. We will introduce that in the next lesson. All right, so we have 2 more examples, right? Yep, so that is that will be the end. So let's do this too. So we have 3/4 times -8 minus 3. So that is equals to -2, -6 minus 3. So you have a -9, right? So we have -8, -9. And then 3/4 times -4 minus 3. So that is a -3 minus 3 equals to -6, 0. So that will be 0 minus 3 times 4. So that will be a 1 minus 3. No, 1 minus 3. 3 minus 3. So that will be 6 minus 3 equals 3. So we have 8, 3, 4, 0, and then 0, -3. And then -4, -6. Okay, so -8, -9, that is definitely out of the picture. How about -4, -6? -4, -6 is right here. And then 0, -3. And then 4, 0. And then 8, 3. Do you see what the pattern is? The pattern is 4 units right, 3 units up, 4 units right, 3 units up, right? 4 units right, 3 units up. And then, so now, do we agree that we don't even need the -8, -9? I know that is out of the picture. So -8, -9, that is should be around like right here, right? I just guessed that is out of the picture. And then you show a straight line, connect these points to get the equation. I hope that they connect, because they that is out of the picture is hard to eyeball that. So that is the graph of y equals to 3/4 x minus 3. So remember, that is 4 units to the right, 3 units up. This pattern has a name. We will do that in the next lesson. Okay, before we conclude this lesson, let's do the last one. The last one, I gave you a different graphing paper. There is no the best to me. The one that I used in this video a lot, that is the best to me, because I have been using that for a long time. But if you go online, you can always find one pretty easily. Okay, last one. -1/2 times -6 plus 3. So that is a +3 plus 3, 6. So that is a -6, 6. And then 1/3 -4 plus 3. So this is a 2 plus 3, 5. -2 plus 3. So that is a 1 plus 3, 0. So that will be a 0 plus 3 equals to 3, 2. So that is a negative 1 plus 3. And then 4. That is a negative 2 plus 3. 1. 4. So that is a negative 2 plus 3. Oh, 6, 6, 6. So that will be a negative 3 plus 3, 0. So we have negative 4, 5, and then negative 2, 4, 0, 3, 2, comma 2, 4, comma 1, and then 6, comma 0. Okay, let's plot them. Negative 6, negative 4. Wow. Okay, negative 6, negative 4. That is right here. And then negative 4, negative 5. I mean negative 4 positive 5. Hold on. Negative 6, 6, huh? Come on. Negative 6, 6. And then negative 4, 5. And then negative 2, 4. And then 0, 3. So the pattern is 1 unit down and then 2 units to the right. And then we have 2, 2, 4, 1, and then 6, 0. So if you keep on moving, I can tell the rest of the points. So they will be right here, 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 and there. On the other hand, on the other side, these points, right? Because I grabbed the pattern, is 2 units down, it's 1 unit down and 2 units right, and then you sketch a straight line to connect these points. And then make sure you draw an arrow on each end. So there you go. So that is the graph of what? That is the graph of y equals to negative 1/2 x plus 3. So if a point is on the line, so for all the points you see on the line, they are the solution of this equation. So if you have a point, let's say right here 0, negative 8, that is not on the line, that means this point is not the solution of the equation. So that will be the end of this video. If you think my instruction is helpful, let me know in the comment section below. Very important, like this video, let more people see it, share the video for me, subscribe to my channel. Appreciate your help really much. I see you all in the next lesson. Signing out.